Yes, welcome to today's discussion on assignment for electromagnetic waves. Please refer my channel for previous questions on same topic. So with your permission, I want to start today's assignment session for electromagnetic wave. Thank you. So before I'm going to start the concept. I would like to discuss few points related to what is electromagnetic spectrum. So here, electromagnetic waves. Generally, when charge it is in rest form. What is that? When charge it is rest, it form electric field. It creates electric field. When charge it is in motion, it creates electric field and magnetic field. When charge is accelerating, it creates electromagnetic waves. That means electric field. From electric field, electromagnetic waves. So here, not only that one, in another way, we can define as when electric field is oscillate perpendicular to the magnetic field, then it creates electromagnetic field. So what is spectrum? So spectrum is nothing but group of wavelength or group of frequency. Electromagnetic spectrum defined. That means electromagnetic spectrum means the component of electromagnetic field. They classified according to the wavelength and frequency. This is known as electromagnetic spectrum. What are the components of electromagnetic spectrum? Gamma rays, X-rays, ultraviolet, visible light, infrared, microwaves, radio waves. These are the components of electromagnetic spectrum. See, when we look here, gamma rays, X-rays, ultraviolet, visible, infrared, micro and radio waves. And this classification done according to the increasing of wavelength, so that we can understand that gamma rays are least wavelength when you compare with the radio, where radio waves are longer or highest wavelength. You can see here, when we move from gamma rays to radio waves, wavelength is increasing. Wavelength is reciprocal form to frequency. Frequency proportional to energy, so that wavelength is reciprocal to frequency and reciprocal to energy. That means if you increase in wavelength, energy and frequency both will be decreasing. So this is according to the wavelength. So according to wavelength, gamma rays to radio waves, where gamma rays are least wavelength and radio waves are highest wavelength. Obviously, that means wavelength is opposite to the energy and frequency, reciprocal to energy and frequency. So that if we shift from radio waves to gamma rays, that means from radio to gamma, energy is increasing, frequency is also increasing. See, radio waves are least frequency, least energy. Gamma rays are highest frequency and highest energy. Why? Because gamma rays wavelength is small, so that they have highest frequency, highest energy. So here, this is how the components are classified. The components of electromagnetic field are classified according to increasing order of wavelength, decreasing order of frequency and energy. And we know very well E equal to hc by lambda. That means E is inversely proportional to wavelength, so that minimum wavelength is equal to maximum energy. Please don't consider question numbers. After preparing my questions, then I clubbed all into the similar way, because after preparing the question, I clubbed the similar questions in one slide. So please don't consider question number. For easy understanding, I clubbed in similar questions in single slide. Okay, here is the first question. The speed of an electromagnetic wave in a vacuum depends upon the source radiation. Speed of electromagnetic wave increasing as we move from gamma to radio, decreasing as we move from gamma rays to radio waves, is same for all of them, none of them. So here, the speed of electromagnetic wave in vacuum depends upon the source radiation. It is same for all of them. Same for all of them. That means gamma rays to radio waves that travel with speed of 10 to the power 8 meter per second. That means equal to speed of light. Question number 2. All components of the electromagnetic spectrum in vacuum have same. So as I discussed with you, gamma to radio waves, they travel with speed of light, that is 3 into 10 to the power of 8 meter per second. So they have same velocity. The components of electromagnetic spectrum such as gamma, X-rays, UV, visible, infrared, micro and radio, they have same velocity. So for these two questions, just look at this analysis. All components of the electromagnetic spectrum propagate through a medium at identical velocity. That means at same velocity. We have a relation also. C equal to 1 by under root of mu naught epsilon naught. Mu naught is permeability of vacuum related to magnetostatistics. Epsilon naught permittivity of vacuum related to the electrostatistics. This value is 8.85 10 to the power of minus 12 farad. This is 4 pi 10 to the power of minus 7. So that is question number 1 and 2. Related to the wavelength, extremes and atmospheric interaction. Question number 3 and 4. Look here. That's about which is having minimum wavelength. X-rays, UV rays, gamma rays, cosmic rays. So here that is which is having minimum wavelength. So as I've discussed here, gamma, X-rays, ultraviolet, visible, infra, micro and radio. So gamma to radio wavelength is increasing. Radio to gamma frequency is increasing. Your question and our question, which is having minimum wavelength. So obviously out of given concept, no gamma is given. So we have X-rays, ultra, so sorry gamma also given, gamma, X-rays, UV and cosmic. Obviously that is about gamma rays. So gamma rays are having minimum wavelength. Question number 4. Which of the following electromagnetic waves have the longest wavelength? So your longest wavelength, gamma to radio waves, when we observe wavelength is increasing, so radio waves are having highest wavelength, that means longest wavelength. That is obviously C. Question number 5. Which of the following shows the greenhouse effect? Which of the following shows the greenhouse effect? What is greenhouse effect? That is like methane, CFC, methane, CFC, H2O. These gases, these components are trapping the radiation from the earth, and because of that reason there is a little warm condition, and that we call as greenhouse effect. So that is greenhouse effect caused by, that is about infrared radiations. Using E equal to explanation, E equal to hc by lambda, maximum energy correlates with the minimum wavelength, that is about the gamma. Radio waves possess the longest wavelength in the spectrum. Infrared rays are primarily responsible for the greenhouse effect due to atmospheric absorption. Explanation for this 3, 4, 5. It's coming to the question number 6. What is order of energy of X-rays, radio waves, and microwaves? So, what is order in terms of energy? Your question is in terms of energy order. As we discussed, gamma 2 radio wavelength is increasing. Then radio to gamma frequency and energy increasing. So here energy ratio. First of all, gamma to radio waves. So that is obviously, as we know, X-rays. Sorry. Just you can come here. Just I will see here. Just you can see here. Gamma X UV visible. So that is about the energy, which is having energy gamma. Gamma after X-rays. X-rays after ultraviolet visible. So highest energy for gamma, X-rays, and ultraviolet visible, infra, micro, and radio. So now for the here you can compare that spectrum concept to here. So that's about first X-rays are highest energy, then after micro, then after radio. So that is about EX greater than EM, EM greater than AR, ER. And next question, that's about which statements are true related to wavelength. So here the statement, which statements are true, that is what question number gamma microwaves, wavelength of microwave is greater than to the wavelength of the UV. So obviously just we discuss here, when gamma to radio waves wavelength is increasing, this is increasing wavelength, year to year frequency and energy. So our topic is related to only wavelength, so we shift on wavelength concept. So here which statement are true? So microwaves are longer wavelength, no, radio waves UV after micro. Okay, this is correct. That means next IR is lesser wavelength than UV IR. So as we know, gamma X UV visible I M R. So microwave wavelength. So year to year wavelength is increasing. So microwaves wavelength is greater than, is obviously microwave greater than to the UV rays. Next IR is less than, sorry, IR is less than to UV. IR UV. So this is wrong, because IR is greater than to the UV. You should keep like that. But here it is wrong. So this is wrong. Next microwave is greater than IR. No, microwave is less than to the IR. Micro here and IR here. This is also wrong. Gamma rays have shortest wavelength. Obviously, yes, this is right. So your answer is A and D. What is that? A and D. Energy order is EX greater than EM. EM is greater than ER. Okay, next. Electromagnetic wave. See, this is about the three-dimensional figure for electromagnetic wave. See, and along the y-axis we have electric field, and x-axis we have direction propagation, and z-axis we have magnetic field. So this is about the magnetic field, this is about electric field, and this is direction, wave propagation, direction of wave. So here electric field oscillates strictly on y-axis, magnetic field oscillate on z-axis, Direction of propagation occurs along the x-axis, which is perpendicular to magnetic field. Perpendicular to electromagnetic field. Next, eighth question. An electromagnetic wave has. So here, electromagnetic wave has, that is about, is having electric and magnetic vector perpendicular to each other. Electric and magnetic field vectors are perpendicular to each other. Ninth one. The electric field of a plane electromagnetic wave in vacuum. Electric field of a plane electromagnetic wave in vacuum is. So the question is what? That is, obviously here Ex equal 0, Ey equal to 0.5 cos 2 pi 10 to the power 8 of t minus x by c. Ez also 0. So we have electric field that is in y component, and now the question is what? It is which direction? X, y, z, or what? So here this is Ey. So here electric field in is y direction. What about the direction of propagation of the wave? Obviously that is about x direction. That is what? X direction. Look here for the 8th and 9th. Time varying electric field and magnetic field are mutually perpendicular and transfer to the propagation of direction. In the equation, in this particular equation, the t minus x by c, isolate x as the spatial variable, indicate that the wave travels along the x direction. Here it is a minus symbol, so it travel in positive direction, positive x-axis. Next question. Light wave is traveling along x direction if the corresponding E vector at any time is along y-axis and the direction of B vector that time is along. So wave is traveling in x direction, electric field is in y direction, B is in which direction? This is the question. So here you can see this particular diagram. So electric field that is in y direction, magnetic field that is in z direction, wave propagation is in x direction. So here wave propagation x direction, electric field in y direction, magnetic field obviously it is in z direction. But whether it is positive or negative, that is the question. So here that is all about, it is z axis, positive z axis. Why? Electromagnetic radiation is a self-propagating wave where the components isolate at right angles. The direction of propagation is given by the cross product, that is E cross B. If the propagation is x and E is in y direction, then B also must be in z positive. B here is oscillating in positive y direction. Similarly, z also, that means magnetic field also propagate in positive axis, that's about z axis, satisfying right hand orthogonal principle. Right hand orthogonal principle. Next question, that's about the magnetic field of an electromagnetic wave is given by By equal to, there is a question given, 3 into 10 to the power of minus 7 sine of 10 to the power of 3x plus 6.28 into 10 to the power of t, so 10 to the power of 12t. So now just you simplify this with the, first of all compare this with the normal standard equation. By equal to B naught or A naught, B naught sine kx plus omega t. You can see By equal to B naught sine kx omega t, where B naught is 10 to the power of minus 7. 3 into 10 to the power of minus 7. K is 10 to the power of 3. Omega t 6.28 in 10 to the power of 12. Now question is what? Magnetic field of electromagnetic wave. What is the wavelength of electromagnetic wave? Your question is wavelength. So we know the relation K equal to 2 pi by lambda. Lambda equal to 2 pi by K. So what is K? K is nothing but 10 to the power of 3. What is that? 10 to the power of 3. Now replace here. So the lambda equal to 2 pi by 10 to the power of 3. After that you will get 0.63 cm. 0.63 cm after calculation. Don't worry, I will give quickly. Okay, next question. That's about if c is speed of EM wave in vacuum, its speed in a medium of dielectric constant K, and relative permeability mu r is. So here just c equal, we have a relation that is 1 by under root of mu e mu into e. We have a relation. In place of c we can also consider v also. Okay, that's about how we are interacted. So that is, there is what we placed here, a constant, dielectric constant we placed here, so that the velocity of light ray, the velocity of light in any medium is fundamental. C equal to or V equal to 1 by under root of mu e, where mu equal to mu naught mu r. Permeability in vacuum, relative permeability, mu equal to mu naught mu r. Epsilon equal to epsilon naught epsilon r. Epsilon r is the dielectric. Okay, next, where epsilon is relative permeability, epsilon r, and K is dielectric constant. Now replace here mu in the place of mu, mu naught mu r. In the place of epsilon, epsilon, and that is constant, that is about epsilon into K. Now replace, since vacuum velocity is c, 1 by under root of mu naught epsilon naught, substituting, then you will get c equal to v equal to c by under root of mu r k. So that is about, you can, no problem, just you can look at this is here, no problem. Once again, see, velocity of light any medium is v equal to 1 by under root of mu e. What is mu? Mu equal to mu naught mu r. What is e? Epsilon, epsilon naught epsilon r. And we can consider if dielectric constant, then mu equal to mu naught mu r, mu equal to mu naught mu r. Similar way, epsilon equal to epsilon into epsilon r. In the place of epsilon naught we can consider a medium, or in the place of epsilon, sorry, in the place of epsilon r just we can consider dielectric constant, that is about the K. Now v equal to 1 by under root of mu naught epsilon naught mu r K. Since vacuum velocity is c, so that 1 by under root of mu naught epsilon naught, substitute, then you will get v equal to c by under root of mu r K. According to Maxwell equation, the velocity of light in any medium is expressed as, that is about, you can consider any one of the concepts, that is about 1 by under root of mu naught e. What is that? This is 1 by under root of mu naught e. So this is all about the concept related to the, okay, sorry, here also we can consider 1 by mu epsilon naught, 1 by under root of mu epsilon naught, 1 by under root of mu epsilon naught. So dynamics, that is about the energy dynamics. Amplitude will be shown by C equal to E naught by B naught. Energy density is UE. Intensity shown by I. So here, one question number 1, ask for the average electric energy density formula. Correct formula is what? So that is about average energy density, that is 1 by 4 epsilon naught E square. For the magnet, 1 by 4 B square by mu naught. This is for magnetic field, this is for electric field. Okay, next one. For an EM wave propagating along x-axis, if E max is 30 volt per meter, what is the maximum value of magnetic field? So here we have a relation, that is E naught equal to B naught C, and we need to find B naught. So B naught equal to E naught by C. What is E naught? E naught is nothing but 30 volt per meter. What is C? Speed of the light, 3 into 10 to the power of 8. After replacing the data, simplify, then 10 to the power of minus 7 Tesla. That's about magnetic field. A point source of EM radiation has average power output 800 watt. The maximum value of electric field at a distance 4 meter from the source. So here question is what? A radiation as average power output is 800 watt. The maximum value of electric field. So that means indirectly they are asking about the electric field character. First of all, what is the given data? Intensity given. So that is, we need to find intensity ratio. That is about intensity I equal to P by 4 pi r square. P by P power average by 4 pi r square. So this intensity we can also consider as E square by 2 mu C. If you are taking vacuum, E naught square by 2 mu naught C. This is a relation for intensity. Now, our placing required data, E equal to, then we will consider concept that is about, we want this one, no? So that is cross multiplication, P average into 2 mu naught C by 4 pi r square. 2 by 4 cancel, then you will get 1 by 2. That is E naught equal to mu naught C power average by 2 pi r square. Replace mu naught 4 pi 10 to the power minus 7, C 3 into 10 to the power 8, P average 800 watts, 2 pi. What is R? R is nothing but 4. After replacing that, you will get 54.77 voltmeter. Next question. The amplitude of electric field in parallel beam of light intensity 4 watts per meter square is. So here equation of intensity formula is what? That is about the energy in terms of energy density, that is 1 by 2 epsilon naught E square C. 1 by 2 epsilon naught E naught square into C. This is about the equation for energy intensity. Rearranging its amplitudes, then E naught square equal to 2I by E naught C. Epsilon C. E naught square equal to 2I by epsilon naught C. Substitute values. 2 is what is 4? Intensity is 4 watt per meter square. Epsilon naught 8.85 10 to the power minus 12 C. Okay, here is given. So epsilon value and C value, after replacing you will get 55.5 Newton Coulomb. Next one. If epsilon naught and mu naught are the electric permittivity and magnetic permeability of free space, and epsilon and mu are the corresponding quantities in the medium, the index of refraction of the medium in terms of the above parameters. So we need to find the refractive index concept with the above parameters. That's about, just go here, the velocity of light in vacuum. What is that? That's about C equal to 1 by under root of mu naught epsilon naught. Velocity of medium V equal to 1 by under root of mu e epsilon. Here mu naught epsilon, here mu and epsilon. This is in medium and this is in vacuum. The index of refraction is defined as ratio of speed of light in vacuum and speed of light in medium. So replace your vacuum is what? 1 by under root of mu naught epsilon naught, and speed of medium 1 by under root of epsilon. After simplification, you will get that. What you will get? We will get. So under root of mu naught epsilon under root of mu by epsilon, under root of mu epsilon by under root of mu naught epsilon naught. So this is about the relation. Now you recycle. So this is all about the 1 by root means what? 1 by 2. So that mu epsilon by mu naught epsilon naught over 1 by 2. Do you have this option? No. Mu naught is obviously no root. Mu, okay. Mu epsilon and mu naught epsilon. Okay, this is right. Next one. In an electromagnetic wave, the electric and magnetizing fields are 100 volt per meter and 0.265 ampere per meter. The maximum energy flow, that is the magnitude of the maximum rate of energy flow, that means Poynting vector, is calculated as a product of field amplitude. So Poynting vector is nothing but S equal A cross B by mu naught. So here already given, what they given? Electric field given, magnetic field given. So simplify, where mu naught is considered consistency, so constant value. So now S equal to E cross B. What is E? E is nothing but 100, B is nothing but 0.265, and multiply both, then finally you will get 26.5 watt per meter square. Maxwell additions. So what is addition? Maxwell considered displacement current and momentum. This is the hypothesis for the dE by dt. So according to the Maxwell question, hypothesis, changing electric field acts as source of the magnetic field. So here Maxwell concluded that one, changing electric field produces the a changing electric field acts as a source of the magnetic field. That means if there is a change in electric field, the changing of electric field producing magnetic field. See, changing of electric field generating magnetic field. This is all about the Maxwell hypothesis. And here momentum initial and momentum final. How momentum is transferred. So you can see here. Radiation related to the radiation pressure and momentum transfer. A radiation of energy E falls normally on a perfectly reflecting surface. The momentum transferred to the surface is, see here, momentum P equal to E by C. Momentum P equal to E by C. So similarly, momentum P initially equal to E by C. This is about the perfect reflecting surface. So it is a Pi. This is about Pf. Pf equal to E by C. But this is opposite to this one. So that it is minus. So and change of momentum P equal to final momentum minus initial momentum. So that minus E by C. So that is about 2E by C. Okay, minus 2E by C. But remove this minus. Just you have to consider 2E by C. You can see initial momentum is E by C, and the final momentum is, for a perfectly reflecting surface, the final momentum is minus E by C. Change in momentum Pf minus Pi, which is about 2E by C. Radiation pressure intensity 0.5 watt per meter square. Or striking a metal plate, the pressure on the plate is, we know P equal to I by C. Here P equal to E by C. In terms of pressure, this is about the momentum. This is for momentum. This is for pressure. P equal to I by C. This is about pressure character. So P equal to I by C, and replace the things. I is what? I is 0.5 intensity, and C is what? 3 into 10 to the power of 8 meter per second. So replace data and simplify, which is about 0.1 into 10 to the power of minus 8 Newton meter square. Newton per meter square. Displacement current on a large parallel plate capacitor whose plates have an area of 1 meter square and separated by 1 millimeter distance is being charged at a rate of 25 volt per second. If the dielectric has a constant of 10, the displacement current at this instant. You can see this is about plates, and both the plates are separated by 1 millimeter distance. The area of plate is 1 meter square. There is a dielectric is introduced, that is about K equal 10. Now we have a formula capacitance. It depends on area of plate. Capacitance is opposite to the, means inversely proportional spacing between the plates. Then we got C is proportional to A by D. Remove proportional to C equal to epsilon into A by D. Now just go to the capacitance, that is about A. Okay, there is the intrinsic dielectric, you can consider K. So that is about A epsilon naught K by T. Replace the data. Epsilon is 8.8 10 to the power of minus 12. Area of the plate is what? 1 meter. Dielectric constant is how much? 10. And what is the spacing? 1 millimeter. That means 10 to the power of minus 3. Okay, clear. It is meter, area meter, so spacing also should be in meters. So 10 to the power of minus 3. After replacing, C equal to 8.8 into 10 to the power of minus 8 farad. Now your question is what? Displacement current. What is displacement current formula? ID equal to C into dV by dt. C into dV by dt. What is C? 8.85 10 to the power of minus 8. What is dV by dt? Here already given. That is about charge at the rate 25 volt per second. So replace the data and simplify. That's about 2.2 microamperes. Rates of change in capacitive systems. Next question. Instantaneous displacement current of 1 ampere in the space between parallel plates of 1 microfarad capacitor can be established by changing the potential difference. So here, first let us consider the relation between the charge capacitance. So as we know, charge is proportional to applied voltage. So CQ equal to CV. Q equal to what? CV. Q equal to CV. So ID displacement current derivation, that is from that C equal to, ID equal to C into dV by dt. Now dV by dt equal to ID by C. ID by C. Now replace here, what is displacement current to? That is 1 ampere. What is capacitance? That is about the space between parallel plates of 1 microfarad. Okay, 1 microfarad means 10 to the power of minus 6. After replacing, you will get 10 to the power of 6 volt per second. The four pillars of electromagnetic waves mechanics, that is spectromagnetics, what are there? That is about wavelength, energy and universal capacity. Wave, how wave travel, that is about the travel in orthogonal propagation. Electric field, perpendicular magnetic field propagation. Both electric field and magnetic field propagate perpendicular to the wave propagation. Then energy intensity, what are the energy dynamics, what we recall from the previous this question, that is about the intensity calculation, Maxwell find field limits and Poynting vector, Maxwell equations. So from Maxwell equation applications to displacement current to mechanics and momentum transform, radiation pressure. Thank you. Please refer my channel for another question. Thank you.